Welcome to the Greenplum Demo. Greenplum is the foundational component of our data lakehouse solution. So essentially what Greenplum allows is to process your structured, unstructured, and semi-structured data. And you can apply different types of analytics on top of it. For example, you could do complex OLAP queries like summary queries, windowing queries, and stuff like that. You could do text search with natural language processing capabilities. You could do machine learning type analytics. You could create vector embeddings. You could do geospatial analytics. So I'm going to show you a quick demo of this using a synthetic patient data, where we are going to look at some of the patient information and go through all this sort of analytics. I am using Apache Superset as my user interface for this, but Greenplum works with most visualization tools like MicroStrategy, Business Objects, Jupyter Notebook, any SQL editor, and all that. The first query here is to demonstrate Greenplum's analytical capabilities with complex windowing functions. This is essentially showing basically what I've done here is I've received all this data and stored it in an external S3 storage. And Greenplum is going to query the data in that external storage and return it. This is seamless. The user doesn't need to know whether the data is on S3 or spinning disk or NVMe drive. But generally in the data lakehouse design, the raw data is usually stored in a low-cost storage device to get the cost efficiency. That's what I've done here. It's really seamless. The user won't know where the data is. But at this time, this data is actually on an S3 bucket. So this goes out real time, gets data from there, and gives it to us. Okay, so that's how you take advantage of low-cost storage tier. And then the next query we will show is that a bit more complex windowing analytics, like things like looking for average, sum, and slicing and dicing of the data and stuff like that. So this is your typical complex analytics query, looking at in this case, I am looking at the demographics data and stuff like that. And I can also create charts to visualize this if that's what is preferred. Sort of like understanding what is going on with my data here. Now that we got a good understanding of the data, let's do some more analytics with it, right? I want to look at all my patients within a location. Like for example, I looked at my demographics, I understood it. Now I want to focus on my patients in Boston, like maybe a certain kilometer range. So this is a geospatial data. I have patients address. So now I can do some geospatial query to say, to get all the patients within the city center. So this query here really does that. It's using all geospatial functions to find that, right? So this is saying I have 78 patients within 50-kilometer radius of Boston City Center, and average distance is 21, right? So this is my subset that I want to work with. You could do all sorts of analytics with this. The idea here is to show that you can do really quick geospatial queries, all inline, simple with simple SQL query. Okay. Now I want to find out, okay, for this set of data, and they are talking to some providers, meaning hospitals and clinics and stuff like that. So I want to find out who are the influential providers. So this is essentially a graph problem. This is finding who are connected to who and who is the most influential in the network, right? This type of analytics can be applied for anti-money laundering, identifying like people of interest. Like, for example, if you're looking at counterterrorism type use cases, you want to know who is the most influential person. It's all that. In this case, we are looking for who is the most influential provider. So this is really about creating graph data and then looking at doing a page rank of the data and then finding out. I've done some pre-work here, but this is to show that just do a page rank of all the providers, and the one with the highest rank is going to be the most influential provider, right? So this is again like a graph analytics type. You're looking at who is connected to who, and then ranking them based on the connections, and then figuring out who is the most influential provider. This is sort of like how your web pages get ranked and figure out which links are more relevant and which links are not. So that's essentially can be done with like a bunch of SQL statements with Greenplum. So just to recap really quickly, we saw complex analytics, windowing functions and stuff like that. We saw geospatial capabilities, and then we saw graph capabilities. Now I want to go and look for some advanced text capabilities. Like for example, I want to look for patient notes and find out if I have some patients with who are taking medroxyprogesterone or Provera, right? Basically, I'm saying, okay, I have this set of patients and I want to look at certain information about them. So that will help with my analytics. So again, right now we are getting into text analytics capabilities. So I have a module called GP Text embedded in Greenplum. That's what is going to give me the text analytics capabilities. In this case, what I am doing is I am looking for medroxyprogesterone, and I am allowing for one typo error, meaning if they have made a typo, any one typo within this word, that's okay. I've asked the process to tolerate that. And in this case, I asked the processes to tolerate two typos. For example, if the physician typed 2 R's or 2 R's here, or instead of Provera, if they type Provera, anything like that, it's going to tolerate that and bring the results back. And it's also going to look only for data beyond after this timestamp. And then it's going to look at only discharge and progress data types. Okay, sorry, this is just a simple error with my syntax. So I'm just gonna do this real quick. My bad again. So I just made when I typed some numbers, it got in there. So that's why it's wrong. So as you can see here, I searched for progesterone or Provera in the patient's note. This is actually looking into the text of the data. And then with all these conditions you gave, like, okay, ignore a typo and stuff like that, it processed and it gave you the subset with this information. Great, right? So you are now able to do text analytics as well with the data stored in there. Now, this is great, but I also want to marry this with data externally available. Like, for example, I want to take this piece of information and bring some data from an external website, let's say some PDF sitting in some government websites or some academia or something like that, and sort of do analytics with it. So to demonstrate that capability where you are doing text analytics involving data outside, I'm going to show this process. So here what I've done is I've referred to a bunch of PDF files sitting in different websites. This is in thoracic.org, UNH, VA.gov, all these places. And I'm going to create an index. And then what this does is it's going to tokenize the content there and store it here. And then I'm looking for pneumonia. So I run this. Right now, I haven't stored this data, but when I created the index, it tokenized and it stored it in the index. We didn't really cache the whole thing. We just passed it real time, tokenized it, and it stored in the index. And using that index, it searched and it brought these 4 things. As you can see here, these are probably pneumonia related. You can say that directly based on the URLs. There is pneumonia, pneumonia, pneumonia. But this doesn't see, there is no pneumonia in the URL. So let's go and look at what's going on with this, right? So if you do see this, and there should be some content referring to pneumonia in this. That's why I'm sure we picked it up. So we go here and we search for, yeah, right there. So increase in community acquired pneumonia. So you get that, right? So you basically can go outside of outside of what is in Greenplum and tokenize that and use that. And then you can start joining this and use this information to query the data that is within Greenplum. The power of Greenplum is that you not only can analyze what is inside, you can actually go and get data. This is unstructured data. As you can see, this is all PDF files. we were still able to tokenize them and search through them with the keywords that we want. And again, once you have data like this, you could do all sorts of natural language processing and other things like I showed you, where you can say, look for certain boundaries. If this word is there and that word is there within 5 lines of a certain keyword, so you could do all sorts of complex text querying with this. So we are able to do geospatial analytics. We are able to do graph analytics, now text analytics. Now I want to do vector processing, because most of these AI use cases, the modern data processing involves some type of vector embeddings and stuff like that. So here is something I've done with I used a sentence transformer model out there to create embedding model. And all I can all I have to do is, this is my Python code that runs the model and creates vector embeddings. So all I have to do is create a function called embed.text. Now this whole Python code, this is a Python code based function. So you can write any Python logic or anything like that, and then make it into a function. Now, when I run this, it's going to use this function real time and do this transformation and do the processing. So the power of this is that if you want, if whatever you can do in Python, you can make that as a user-defined function and run it on the Greenplum node. Okay, that's what we will see in the next query here. So I'm doing this vector search right now. In this vector search, if you see here, this is what I want to check for, medroxyprogesterone, but I have to give the vector format of that to my query. So to convert this into vector format, I'm calling this function that we created. I showed you with the other, just before this, I showed you this. This is the function with the Python that we wrote. So this one, as I run this, when I run this query, it's going to call this real time, convert a vector, create a vector equivalent for this, then pass that into this query, and that will go look up against the data stored in Greenplum, and then it'll give the results back to us. So sorry again for some of these typos. As I'm typing, it just adds some characters. So sorry about that, but here is that. So this is right now, it's doing all this real time. It's processing, it's creating the vector embeddings. It's using the vector embedding to go and do a vector cosine search, and it brought back all this relevant information. So you could also make it much more faster by pre-processing and storing it. But again, if you have to do it runtime, you can do that as well. This is to demonstrate the capability of that. Okay, because this is a function, you can use it in any way you want, just like you would use any standard SQL function. Okay, that demonstrates the vector processing capabilities of Greenplum. Now let's get into the big part, which is AI ML processing, right? So a big thing about machine learning is you create features. Like for example, if you have date of birth, but the model requires age, then you need to convert, you need to actually calculate the age from date of birth, right? That's a new feature. Or you could create additional, you could do like PCA type dimensionality reduction and create those dimensions. So there are a lot of ways you might end up creating new data. And this sort of shows, in this case, I am calculating a bunch of things, like I said, age and days and stuff like that, uh, to because my model needs these things. So this sort of like shows you how you can use different functions. You can use statistical functions also to do that. So let's just, I'm just not going to, I already created it, but this is just going to show you how you created it, because I have used this in the next query, right? So this is just to show you that you can easily do this using SQL functions. Now let's go use this, my query here. So in this case, I am creating a training data set. Again, I'll use this later, so I'm just going to show this to you. So all I have to do is just join the features that we created with the labels, and then that will become my training data set for my. There are many ways to do this. This is a really quick and easy way to do that. Okay. And then I will show you the main thing, which is the regression training. So I used the data sets I created. Basically, I had created additional features, and then using the features and marrying it to the label, I created a training data set. And in here, I'm using a logistic regression model because I want to calculate a probability here. Um, so I'm using logistical regression model, and this function called log regression train is going to train the model. This is my source data set, meaning this is the data set with my features and labels and stuff like that. This is the name of the final model, the trained model, right? And this is what I am predicting. I'm predicting the probability of readmission in 30 days. So that is like, what is the chance that this person will get readmitted in 30 days, given these parameters like age and certain number of days they were counted, the complex diseases they had, and the gender and all of that, right? So I just picked a few features. Obviously, this is the data science part. This is where you will pick out what your features are, which gives you more accurate predictions and stuff like that. Okay. So in this case, all I have to do is run the model. And in this case, because I already trained the model just before this, it's showing that output name already exists. But if I don't have it, it will create the that output model and give us the trained model. So in this case, essentially what this is saying is that output table already exists. And that's because just in preparation for this demo, this recording, I ran this. So the model already got created. So that's why this error is that essentially this is simply saying I could even show it like this. Like if I rename it to something like that and run, it should train it, right? So it just simply says that I can train, and this is what this is basically saying. I've trained it, and this is your model, right? I just have a new model with the whole thing. Okay, perfect. So we showed how easy it is to train a regression model. And this can be, there are 75 different functions that comes out of box, all the way from your basic regression models to classification models, your decision trees, your random forests, and deep learning models and all that. So you get all kinds of models, and it's so easy to do it like this. All right, now we have trained the model. Let's use the model to make some predictions. Okay, so I have this scoring function. So in this case, all I have done is I created a scoring table, and I used this function called predict probability. So it's basically the same thing, logistical regression. Remember we said log regression underscore train was to train the model. Now I have another function called log regression underscore predict underscore probability. This is going to apply this inference, a scoring thing where this is doing prediction based on the data set we give. Okay, so I've created this, and let me show how all these come together in one query. So now let's see the predictions. Okay, so here what I have done is remember we have the predictions scored in scored thing, and then this is my encounters data set. So I just said, okay, give me for this inputs, what's the probability that this person will get admitted? Oops, sorry again. So this editor, if I click on something, it only takes that and executes it. That's why you see this syntax error. So if I click just like this, it should work fine. So this is not a tool problem. This is just a me problem. And when I just hit the cursor, and if it selects something like this, then it get that error. Anyway, so now here you can see that it took all these things for this patient, for this encounter. It just goes and says the probability of readmission is 76%. And in this case, 53%, 73%, and all. So if we train the model, we use the model to make predictions. And this is where you're actually using the predicted results with the other structured data and bringing them all together. Okay, so that shows you the modeling and prediction capabilities with out-of-box functions. And lastly, I want to show you how you can bring all this into one big query. If you're doing complex analytics, right? You may want to do some windowing things. You may want to run the model. You may want to do all these things. In this case, I'm doing 30-day readmission with risk adjustments. So I'm looking at other parameters to decide, adjusted for risk, how is my readmission going to be. So this requires a lot more complex analysis, like, so you can see this query. I'm looking at a bunch of different things, doing some windowing functions to look at what I want, doing some um, processing here, and I'm doing some standard deviation calculations. So basically, this is a very complex process. And as you can see, I'm doing some more averages and statistical calculations. And finally, I'm also doing the readmission probability rate and all of that. So if I have this complex query, idea is, when you start working on an AI project like this, you start with a small requirement, but then you will keep on looking at other things, and then your requirement will get complex, right? So if you have to go to multiple platforms to do multiple things, it's going to take up a lot of time. So, but if your platform is able to run all this in one query, that's really awesome. And that's what Greenplum can do for you. So again, like you can see, it's a complex query with so many different types of logic, different types of processing in there. And it was able to run that. And then it gave you all these things, and it gave you what's the probability with risk adjustments, right? So it gave you all of that. So that is really the power of Greenplum. Again, to summarize, you can do massive data processing, massive parallel processing with Greenplum. You can process structured data, unstructured data, semi-structured data. You can do text analytics, graph analytics, geospatial analytics, machine learning, vector processing, and all that, right? If you need any more details, or if you would like to dive deep into any of this, please let me know, and I will be happy to walk you through that. Thanks again for listening to this demo. Again, if you have any questions, please feel free to reach out to me.